In this tutorial, I'm solving a problem that has two sequential reactions, and we are using information from one reaction to solve for the other. Phosphorus can be used to produce hydrogen bromide, and the question is challenging us and say if you have 0.45 grams of phosphorus, what volume of HBr would you produce at standard temperature and pressure? So the first thing I'm going to do is find moles of phosphorus. Moles is simply mass divided by atomic mass or molar mass. So for phosphorus is 0.450 grams of phosphorus. If you go to periodic table, atomic mass of phosphorus is 30.97 grams per mole. So you will find 0.0145 moles of phosphorus. The next thing to do, in order to get to moles of HBr, we have to find moles of PBr3 phosphorus tribromide, and then we are going to walk forward and see what happens. So I'm going to find moles of phosphorus tribromide by using the information from phosphorus. 0.0145 moles of phosphorus. Now it's 2 to 2 or 1 to 1, but if you don't mind, I'm going to solve it as usual. For every 2 moles of phosphorus in denominator, I have 2 moles of phosphorus tribromide. So it will give me the same number, 0.0145 moles of phosphorus tribromide. Now I'm ready. I go to the second equation, and this time it's 1 to 3. That's my ratio, so I use that to find moles of HBr. So 0.0145 moles of PBr3 times, for every 1 mole from the balance equation of PBr3, I produce 3 times as much, 3 moles of HBr. So we stop at this stage, and what you will find is 0.0436 moles of HBr. Now, last thing to do is you need to convert this to the volume. Just remember, at STP, you don't need PV equal nRT. Rather, hopefully you have memorized that 1 mole of any gas, in this case HBr, is equal to 22.4 decimeter cube of volume. So I put my moles under mole. This is a new ratio, and I solve for variable x. Then again we cross multiply, and that's our final answer. So these two numbers multiplied is equal to 1 times x, which is x, and x happens to be 0.976 dm cube of space. Final answer. Now what I'm going to do is solve the same problem on the next slide. So it's exactly the same problem, but I want to make life hopefully easier for you, not more difficult, by solving it through dimensional analysis. So second slide, exactly the same question, and this is how I'm going to solve it, known as dimensional analysis or unit factor. We start with 0.45 grams of phosphorus. I go after molar mass. So we put molar mass of phosphorus in denominator, which is 30.97 grams of phosphorus for every 1 mole of phosphorus. If you stop at this ratio, you will get moles of phosphorus. Then I continue. Looking at my first equation, for every 2 moles of phosphorus, I will produce 2 moles of PBr3. So 2 mole phosphorus, 2 mole PBr3. They cancel each other out. If you stop here, you will find moles of PBr3. Now we go after the second equation, which is 1 to 3. For every 1 mole of PBr3, I produce 3 moles of HBr. Denominators go away. If you stop here, you simply have moles of your product. Last thing to do is I use information of STP. 1 mole of any gas, let it be HBr, is 22.4 decimeter cube of volume. Now all you have to do is multiply the numerators and divide by the denominators, and you come to the same exact answer, 0.976 decimeter cube. I know many of you will look at this and you tune it out, but it's really simple. Just try it one more time and see what happens. Finally, I just want you to solve as many problems as you can.